Hi, this one will be a pretty simple video, hopefully a little bit faster. So this is more the type of video that I would be making almost on a daily basis, maybe like 3 to 4 videos a week. And this is kind of the time and the amount of time we'll spend on videos versus yesterday's video, which was like 27 minutes long or something like that. So let's go ahead with simplifying exponents. So my title is integer exponents, and just because there's going to be a bit of a focus on it, but I want to talk about simplifying exponents. So when you're simplifying exponents, you have to get used to recognizing your rules and seeing them for what they are. So the first one I want you to recognize in every single situation is the power of 0 or the power of 1 rule. Remember that those are two different rules. We have a to the 0 power will always equal 1. Please remember that the exponent tells you how many times this number is going to show up, and if it's going to show up 0 times, I better not see your base anywhere in the problem. So x1 tells you how many times, and since it's 0 times, I don't get to see any of the a. And then your power of 1 rule just says that if I have a one time, I just have a. So that one's pretty self-explanatory, so make sure that you're not mixing them up. I have a lot of people trying to change this exponent to 1, and that just is not going to work. So it just turns, the entire thing turns to 1. Alright, with that being said, I'm going to do like a super random example. Okay, so the quick example I have is like if you have, let's say, 5 to the 0 power times 6 to the 7th power times 6 to the 9th power over 5 to the 3rd power times 6 to the 20th power, let's say. Okay, so I'm hoping that I'm able to incorporate everything with this one example, and if not, then we'll just do a new example. So here, do I see any power of 0 or power of 1? And I'm just gonna, you know what, I'm just gonna add one more thing here, just so that we are 100% fully aware of what the power of 1 is. So, do we have a power of 0? Yes, we do. We have a power of 0 right here. Do we have a power of 1? Now the thing is that you have to recognize that the power of 1 is just when we have the base all by itself. So are any bases by themselves? Yes. This would technically be a power of 1. Okay, so just make sure you recognize that even if there isn't a 1 there. So what I'm trying to say with this step 1 is that we're going to take care of those first. So 5 to the 0 power changes to be 1, because that's what my rule says. Everything else stays the same, so times 6 to the 7th times 6 to the 9th. Though I'm not changing any of that right now. 5 to the 3rd power doesn't change. 6 to the 20th power doesn't change. 5 to the 1st power, remember that we just want to make sure that it equals itself. So if there was a 1 there and basically it's an unnecessary 1, then we're just going to have it equal to itself. It wasn't there at the beginning, so really I'm not changing anything. It's just going to stay at 5. But again, just make sure that we know that there is a 1 there. Now that we've taken care of the power of 0 and the power of 1, we go ahead and go to our step number 2. Let me take this example over. And then before I do that, you can go ahead and try this example. So you're going to make sure that you are taking care of the power of 0 and the power of 1. So go ahead, pause this video and try the example. Okay, pause the video. If you tried the example, great, I hope you did. So 3 to the power of 1 is just 3. 4 to the 0 power is just 1. Remember, anything to the 0 power is just 1. And then 5 cubed. Now the only thing I can do is just keep simplifying here. 3 times 1 is just 3. But I can't do anything with 3 and 5 to the 3rd power. They are not like bases, so I'm going to leave those alone, and that is all I'm able to do. Okay? Alright, so moving right along, product of powers. So when I say product of powers, I am making sure that if I have a fraction, I am taking care of my products first before I try to do any dividing. So make sure we're taking care of our products first, and then also make sure that everything is simplified. So I didn't do this in the last step, but 1 times anything is just itself, so I really don't need that 1. I'm just going to have 6 to the 7th times 6 to the 9th over 5 cubed times 6 to the 20th times 5. Alright, so now I can look at these products individually. Remember that products have to be the same base. So when they're the same base, I can add their exponents. So here's my same base, 6 and 6 being multiplied. So I do 6 to the 7 plus 9. And then I go ahead and look at my bottom. So just to recap, make sure that we know that our exponents get added. And at the bottom, I have my 5 and my 5 that have the same base. So those are the ones that I'm going to take care of. So I'm going to add their exponents. Okay. Notice that we don't have an exponent on the 5. But I know that that is actually an invisible 1. So make sure that you write that for yourself or know that for yourself so that you can add them correctly. So that's 5 to the 3 plus 1. And then remember that whatever I don't simplify or don't do anything with, I just rewrite. So 6 to the 20th, I rewrite. Okay, and now to rewrite the entire thing. So now we have 6 to the 16th power over 5 to the 4th power times 6 to the 20th. Okay, so can I do the product rule anymore? Once you realize that you can't, you stop there and move on. Alright, and you can pause the video. Here is an example where you can use both of those steps. So making sure that we take care of the power of 0, power of 1, and then the product rule. Okay, hopefully you paused the video. If you did, please remember, again, to the 0 power, it means it equals 1. To the first power means it equals itself. And then everything else, I just rewrite. Anything to the power of 1 is just itself, so I don't actually need to rewrite the 1. It's just 1 times 5 is 5. And then I have here my same bases. So since they are all same bases, I add all of their exponents. Remember that when there isn't an exponent, that means there's exactly just 1. Okay, so then we're going to write 5 to the 1 plus 2 plus 3 power, and that'll be 5 to the 6th power. Again, if you are not trying this on your own, you're going to have difficult time with them. And then next thing would be handling the quotient of power. So I'm going to take my problem that I had over here, and now I have done my first and second step. So taking care of my power of 0, taking care of my power of 1, and now we take care of the quotient. So here with the quotient, remember that that is again with the same basis. So the same basis that I have here are my base of 6, top and bottom. I know it's a quotient because they're being divided. So I can just kind of write this out a little bit better for myself and write 6 to the power of 16 over 6 to the power of 20. I can still have my 5 to the 4th power being multiplied, but the only ones I'm going to subtract are going to be the exponents on my 6. Okay, nothing else will change. Now this we might have not seen yet, so just be careful with this part. When we do my top exponent minus my bottom, this answer ends up as a numerator, which means it ends up without a denominator. So we're going to have 6 to the power of 16 minus 20. Okay, so this right here turned into this. However, I did have a denominator, so I have to leave my denominator there, which is 5 to the 4th power. Okay, so just to recap, 6 to the 16th divided by 6 to the 20th is equal to 6 to the 16 minus 20. Remember that we do our top exponent minus our bottom exponent. And just as our rule says, whenever we have a to the m over a to the n, we do a to the m minus n. Notice that this does not have a denominator. It is no longer a fraction. And when that happens, we always assume that there's a denominator of 1, which means a to the m minus n is a numerator. So that's important because when you have other numbers going on, you need to know where they belong and where they don't. Okay. All right, and then to simplify this, that would be 6 to the 16 minus 4. Remember, that's a positive 16 minus, not 4, minus 20. Different signs means you subtract, so you should get 20 minus 16 is 4, and then keep the sign of the bigger number. So this is 6 to the negative 4 over 5 to the 4th. All right, go ahead and try this following example. So you can go ahead and try this one. Make sure you pause the video and try it out. And if you tried it, great. So remember here, everything is done. We can't do product rule. There's no zeros or ones. So the only thing next to do is the quotient rule. So you have to take care of your 3's with the quotient rule. So remember that we're not doing anything with the 2 squared, so that stays at the bottom. But the 3's we do. Just as a little reminder, a to the m over a to the n is equal to a to the m minus n. This does not have a denominator, which means it does end up in the numerator. So you don't have to think about it too much. It will always be there. And then you have 3 minus 5. Remember to always go from the order that it is, top to bottom, or left to right, depending on how it's written. 3 minus 5. Get your number line or your rules out. It's negative 2. And then we have 2 squared at the bottom. So this is as far as you would get with this example at the moment. And then moving on. So you would want to check again that your problem. So again, here I'm bringing my problem from the last one. Make sure that this problem has, whether it has a power of 0 or power of 1, there's no power of 0 or 1, so I can move on. But just know that if there was, then you would do exactly what we did in step 1 and take care of those first so that it doesn't get too complicated. Okay, and then so now here we do have to worry about the negative exponent. So that's, I'm actually going to bring that over with me because I do need it. Oops. Okay, there we go. So now we take care of any negative exponents. Remember, we do not want any negative exponents. Okay, so all of your answers should not have negative exponents. As I've stated before, you'll get a little bit of credit, but you need to make sure that you're not using that. So with negative exponents, it basically tells us that if it has a negative exponent, it you do the reciprocal, which means it ends up on the opposite side of the fraction. So this is a numerator at the moment. Remember this, anything that doesn't have a denominator is over 1. So it is a numerator, it goes to the denominator, and my sign changes to positive. Similarly, if I had it in the denominator, I would actually do the opposite and bring it to the top and make it positive, and then my 1 would be at the bottom. So with knowing that, basically, if it's negative and it's in the numerator, it goes to the denominator, and vice versa. If it's negative in the denominator, then you take it up to the numerator. So in this case, make sure that we always have our fraction ready. We can simplify later, so if I end up with a 1 at the bottom, I can then go ahead and simplify to just the top part. But just to not confuse yourself, start with a fraction. So 5 to the 4th is already with the positive exponent, so that stays where it's at. The one that has the negative exponent is the one we want to move. So we want to take that to the bottom. So we're going to take the 6 to the negative 4 to the bottom, but we're going to change the sign. So now it's going to be 6 to the 4th power. Now remember that all I'm doing is I'm changing it from being up at the top and dividing with 5 to the 4th to coming down to the bottom. Whenever you're changing that, it's just multiplying with whatever's already there. So since here I already have my 5 to the 4th, it is multiplying with this. It's just joining it right next to it. And then you see how I have nothing at the top. Whenever you have nothing, that's where you put your 1. Okay. Another quick little way that I could do this is if I just look at this separately and just do the 6 to the negative 4. According to my rule, I'm always going to put the 1 at the top and then do my 6 to the 4th. Notice that takes care of knowing where my 1 goes, and then I just have to make sure that I don't forget about my 5 to the 4th and bring it over here as well. And as long as I don't forget about it, then we're still good. These are both the same and correct examples. Okay, and then if you want to go ahead and do an example, I'll go ahead and do actually the one that we had over there from the last problem, which is 3 to the negative 2 over 2 squared. So similarly, make sure that you're taking care of the negative exponent. Go ahead and pause it and try this question. Okay, hopefully you paused it. Again, we're taking care of this negative exponent. So it tells me that any negative exponent is equal to 1 over the same thing but with a positive exponent. So the same base but with a positive. And then now we just have to make sure that we don't forget about our 2 squared that was already at the bottom. So it's still there. Okay, and then that is your final answer, 1 over 3 squared times 2 squared, and then an even better answer would be 1 over 2 squared times 3 squared. I don't know why we always want things in order with our math. Okay, so we're going to stop there. Usually once you're done with all those steps, you have taken care of everything that you need to. Right, and then last few notes for me, you might want to pause the video and write these for yourself. So this is basically like step 1, 2, 3, 4. I guess in the simplest way that I could write it. So always take care of your 0 and 1 exponents. So always make sure that those are simplified because you don't want to have them and do extra work that you don't need to. And then there are the rules. A to the 0 is equal to 1 and a to the first power is equal to a. If you don't have a fraction, if you have a fraction for the next step, make sure you simplify top and bottom separately. So first do your top, simplify that, then do your bottom, simplify that. Don't start messing around with the quotient rule just yet. So at this point, you will usually encounter the product rule and the power of power rule. So I wrote both of those here as well. Make sure you write them for yourself. Again, pause the video so that you can take those notes. After that, if you still have a fraction, you use the quotient rule if needed, but you might not have a fraction, so you might not need it. And the very last one is leave anything with positive in its place. Anything with a negative goes to the opposite part of the fraction and turns positive. And I do mean a negative exponent. Okay, just to be clear. So I'm talking about positive and negative exponents.